Hello there, welcome to my first sort of introduction into Radians. Now, when I was first introduced to Radians, I hated them, but my teacher always used to say that previous years always used to find them easier than degrees. And after actually discovering what they were and how you could use them, I love them. I love them. So much easier than degrees. It just uses smaller numbers now. 1 radian is approximately equal to 57-58 degrees, but we don't think of radians in this way. We think of radians in terms of pi. Now, pi, if you have pi radians, 1 pi radian, that is equal to 180 degrees. This is sort of your center for radians. And now, both, then you will have like a scalar. 2 pi is equal to 2 times 180, which is 360 degrees. So this whole angle is 2 pi radians, or 360 degrees. This little theta bit is something else, as we'll discover later. Pi over 2 radians is equal to 90 degrees, and funnily enough, somehow pi over 4 is equal to 45 degrees. Enough of the sarcasm, and from this you can see that if one of the pattern pi degree an amount pi radians in terms of degrees is in some, it will be some scale factor of 180. And there it's 2, and so it's 2 times 180. There pi over 2, 180 over 2, pi over 4, 180 over 4. So now, I'd like you to work out what is 2 pi over 3 radians. Now, let's think. Let's substitute in 180 into that equation. So you have 2 times 180 over 3, which is equal to 360 over 3, which is equal to 120. That's it. That's how easy it is. Or on the other hand, you could be asked to convert 270 degrees into radians. And then you just have to think of 270. What would you multiply 180 by to get 270, or divide? Now, 270 goes into 90, so does 180, so it's a common factor, so it's equal to 180 over 2, and then times that by 3, because 90, that's 90, times 3 is 270, which is equal to pi over 2 radians times 3, which is equal to 3 pi radians over 2. And that is it. That's how you convert radians to degrees and degrees to radians. Now you've got this arc is equal to r theta, which is the radius times some angle theta. Now, this doesn't work for degrees, this only works for radians, this formula. So, let's go. You may be asked to work out major arc PQ or minor arc PQ, and this matters because major arc PQ is basically the bigger one, and minor arc PQ is the smaller one here. So let's say the radius of this circle is 12 centimeters. Well then, and theta is equal to 60 degrees. Find r theta. Now you may be quick to sort of think 60 times 12, 720, but no. We've got to convert this to radians. So 60 degrees is equal to 180 over 3 is equal to pi over 3 radians. So then r theta is equal to 12 times pi over 3 equal to 12 pi over 3, which is equal to 4 pi. That is the length of that arc. And that is why it's a lot easier to work in radians, because that will be exact. Whereas degrees you may have to round up significant figures, decimal places, but with radians it's exact because it's in terms of pi. Now let's label this x. You may be asked to find area XPQ, and now there's a formula for area that you must remember: a half r squared theta. Now this is the area for this is the formula for finding this area bounded by the arc PQ and x with theta here. So let's substitute the values in. It's equal to a half of r is equal to 12 squared times pi over 3, which is 60 degrees pi over 3 radians. Then you get a half 144, not 44, a half of 144, which is 72. I'd just like to write it out in full, times pi over 3, which is equal to 72 times pi over 3, and then as you clean it up you get 72 pi over 3, which is equal to 24 pi. So again, the area bounded by the arc and the radius is 24 pi. And this is why it's a lot easier to work in radians, because you get exact answers and the sums are normally smaller when compared to using anything up to 360 degrees. Normally in a circle the most radians you'll use is 2 pi radians. And I'll finish this one, and if you have any questions or comments, just leave a comment and I'll get back to you as quick as possible. And I'll also try to post some exam questions with radians. Thank you, bye.